Welcome, friends. Now let us see the feedback circuit discussed in our previous lecture a bit more detail. So let's use two push buttons connected here, S1 and S2, as shown in the figure. S1 is going to control what should be X1, and S2 is going to control what should be X2. So let's see the various actions. So the feedback circuit is as shown, and because of this x1 is same as y2 and x2 is same as y1. Okay, let's say switch s1 is closed. So when switch s1 is closed, then x1 goes down to 0 because s1 connects this point to ground, so x1 becomes 0, and because of the NOT gate y1 will become 1, and this y1 becomes x2, and because x2 is 1, now y2 becomes 0, and this 0 comes back here, and now we don't need any more switch to be closed, so we can open now. Just open the switch. Now x2 x1 is same as y2, y2 is 0, therefore x1 will be 0. Because x1 is 0, y1 will be 1. Because y1 is 1, x2 will be 1. Because x2 is 1, y2 will be 0. And this 0 back here, and that continues. So this repeats. How long this repeats? Till there is disturbance. So what is disturbance? The disturbance now is S2 is closed. The disturbance now is S2 is closed. The moment S2 is closed, X2 is forced to become 0. And since X2 becomes 0, Y2 should become 1. And this Y2 comes back as X1. Therefore, X1 becomes 1. And because X1 is 1, Y1 becomes 0. So now we have a different state from 0 1 0 state. Now it has come down to 1 0 1 state. Now let's open S2 and see what would happen. S2 is open now because Y1 was 0. Y1 was 0. Therefore X2 will be 0. And if X2 is 0, then Y2 should be 1. And because y2 is 1, x1 will be 1. If x1 is 1, y1 has to be 0, and this continues. So 1 here, 0 here, 1 here, back here, 1 here, 0 here, 1 here, back, and this repeats. So this repeats. Now what is assumed is when you are talking about S1, when we are talking about S1, we are assumed that S2 is open, and when we are talking about S2, we have assumed that S1 is open. Therefore, when we talk about S1, S2 is open means Y1 is free to change its value, can be either 0 or 1, doesn't get forced by S2 because S2 is open. Same way when you are working with S2, then we assume that S1 is open. That means this Y2 is free to change the value of x1, and that's it. Now if I assume this as my output, so if I assume this as my output, then when do you think my output is going to be 1? My output is going to be 1 in this case. This happens when S2 is closed. Therefore, I can say S2 is the one which sets the output. And when the output becomes 0, the output, that is Y2, becomes 0 when S1 is closed. So this is reset action. So this is going to behave like a set action. This is going to behave like a reset action. So overall, this can be assumed to be a switch, a switch which is used to control the bulb on or off. So when you press this push button for a moment, the bulb starts glowing, and when this is pushed for a moment, then the bulb stops glowing. So this whole thing acts as a simple switch where the switch is pushed down, that is equivalent to pressing S2. The switch is pushed up is equivalent to pushing S1. So that's what is a multi-vibrator is. And in this case, what is happening is it has got two states. So that is state 0 and state 1 if y2 is assumed to be output. If y1 is assumed to be output, then they are the opposite of this. Okay, it's state 0, and this remains in state 0 as long as S2 is open, and this remains in state 1 as long as S1 is open. So when S1 closed, then from 1 it goes to 0, and when S2 closed, from 0 it goes to 1. So in the form of state diagram, we can say it is there in state 0, it is there in state 1. So from state 0 to state 1, we need S2 to close, and from 1 back to 0, we need S1 to close. And when both are open, it remains in the same state. Now what is this meant is S2 is closed, which means S1 is open. S1 is closed, which means S2 is open. So that's the thing. So till it is disturbed from outside, it is going to remain in the same state. Therefore, we can say that the state is stable state. And in this case, state 0 is stable as long as S2 is not disturbed, and state 1 is stable as long as S1 is not disturbed. So for this S2 should disturb, and for this S1 should disturb. And as long as this outside world don't disturb, the circuit is going to remain either in this state or in this state, whichever state it was there, and hence we can call this circuit a multivibrator with two stable states. That means we can say bistable multivibrator. So that's basic for bistable multivibrator. The implementation details will follow in the coming session. So till then, take care. See you. Bye.